Good morning, all of you. Today we will discuss about the enzyme immobilization and their advantages. Okay, what is the enzyme immobilization? According to their name, immobilization means trapping of our enzyme, immobilize them. Why? Okay, so immobilized enzyme are defined as the enzyme which are physically confined or localized in a certain defined region of a species with retention of their catalytic activities and which can be used repeatedly and continuously. Okay, so the term immobilized enzyme include the enzyme modified to a water insoluble form by the suitable technique. Okay, uh, soluble enzyme used in a reactor equipped with non-permeable ultrafiltration membrane which retain the enzyme molecule inside the reactor. And third is the enzymes, the mobility of which has restricted by attachment to the another macromolecule like the enzymes proteins with the composite resultant molecule being water insoluble. Okay, so what is the advantages of immobilization? This is very important. What is their use actually? Okay, so enzymes can be reused. Okay, this is the main advantage. It can be reused. Then second is a process can be operated continuously and can be radially controlled. Third is the higher dilution rates can be used in the CSTR. Okay, easier product recovery. This is also very important advantages. Product it can be easily recovered by this enzyme immobilization. Influent problem and the material handling can be minimized. Okay, easier enzyme recovery. This is very also important advantage, easier enzyme recovery, because the recovery process is very critical in some cases. Okay, so enzyme recovery process is it gets simple by this enzyme immobilization. In some cases enzyme property activity and stability can be altered, flavored by the immobilization. Okay, so what is the disadvantage? Okay, advantage as well as disadvantage also. So disadvantage of immobilization, mass transfer is inhibited. Okay, second, reduced activity of enzyme. Okay, it can reduce the activity of enzyme and this is the main disadvantage. Okay, when if our enzyme get deactivated, what is the use of that enzyme? Okay, then bursting of immobilization medium to the cell growth. Okay, cells enzymes can leak out immobilization medium. Okay, if we are not properly prepared our medium, immobilization medium, it can leak. Okay, then next is this is the immobilization method for the enzyme, method for insoluble, method for soluble enzyme. This is the distributed according to a solubility. Okay, for the insoluble enzyme, binding and entrapping. Entrap means there. Okay, then binding, cross linking, carrier binding. This is also two type. And entrapping means get entrapping, we can say kidnapping. Okay, entrapping, fiber entrapping, micro escape solutions. Okay, and there are also some method: physical adsorption, ionic binding, metal binding, covalent binding. Okay, so method for soluble enzyme, ultrafiltration membranes we can use, and second, hollow fiber devices. This classification is on the basis of nature of interaction responsible for the immobilization and the nature of their support. What type of support we can use? Okay, the major component of immobilization are require the enzyme firstly, then matrix or carrier, and third the mode of interaction of enzyme and the carrier. Okay, the support it can we can be produce our support by using the organic component or inorganic component. In organic component we can use the polysaccharides, protein chain, synthetic polymer, and inorganic ceramic, glass, silica, alumina we can use. Okay, so matrix carrier for the enzyme immobilization, what type of carrier we use here? Carrier choose can enhance the operational stability of immobilize enzyme, although there no universal carrier number of desirable characteristics should be considered while selecting a carrier. What type of criteria is required for selection of our carrier? Okay, in that first is a large surface area. It requires a large surface area. Permeability, okay, it may be a permeable, it gives a permission, okay, allow for our enzyme. Hydrophilic character, okay, means water loving character is important. Insolubility, okay, if it gets soluble, what is how we can use, okay. Then next is a chemical, mechanical and thermal stability is very important, okay. High rigidity, it get rigid, okay. Then suitable shape and particular size is required for recovery of our enzyme. Then resistant to the microbial attack and regenerability, it is very important for use our matrix, okay. Comparison of enzyme carrier, okay. So non-porous and porous, what is the use of non-porous enzyme character and porous enzyme character? The advantage is low diffusional limitation, okay, for non-porous, because it is a non-porous, that why diffusion is very low, okay. Disadvantage: low surface area, low enzyme loading, use of fine particle, difficult to remove, difficult to use continuously, high pressure drops and limited flow rate. So porous, in the porous there are advantages: the high surface area, high enzyme loading, protection from external environment, okay. This is the advantages of porous enzyme carrier, okay. But there are some disadvantages also: the high internal surface area, high diffusional limitation, high cost, also high pressure drop, low surface area available, broad spores. But um, according to study, the porous enzyme carrier are generally used as compared to the non-porous, okay. So this is the chemical classification of our enzyme. Immobilization method, okay, there are some immobilization physical and chemical method for immobilization, okay. In the physical method, membrane, matrix entrapment and adsorption method are involved, and chemical method, adsorption and covalent bonding, okay. So membrane micro encapsulation, this is the method. In the membrane, polymerized around the aqueous enzyme solution in a colloidal suspension, particle size on the order 100 to 10 micrometer, okay. This is the advantages of micro capsulation. What is the advantages of micro encapsulation? Okay, high surface area to volume ratio, okay. Thin membrane, relatively being attached method. But what is the problem, we can say, what is the disadvantage of this micro encapsulation is more easily damaged than the gel beads, okay. This is the main, we can say, disadvantage of micro encapsulation. That's why it can damage our immobilization membrane, okay. Other membrane immobilization method, HFM, hollow fiber reactor, okay. Hollow fiber membrane, we can say HFM. Hollow fiber reactor use the micro or ultra filtration membrane to retain the high molecular weight enzymes but pass low MW compounds, okay. So enzymes or cells, the substrate and the product outside the membrane, okay. This is the closer view of fibers, okay. Hollow fiber reactor, the two types of cartridge here we use for the immobilization. Next is the entrapment method, okay. There are some advantage of entrapment method, relatively being attachment method, okay. Entrapment easy to perform, and in the industry or day-to-day life, in the practical, we use the entrapment method, okay, for the enzyme immobilization. There are some disadvantage, we can say, the problems: some mass transfer limitation, then cell enzyme leakage, this is the main problem, and some cell enzyme deactivation also, okay. Covalent bonding, in the, we can say, the sharing of electron. But here covalent bonding, how it works: most extensively used method of immobilization due to the high bond strength. Okay, three elements: structural, polymer, enzyme molecule, and bridge molecule. Activity of immobilized enzyme is a strong function of hydrophilicity of the structure polymer, covalent bonding to support. Bridges molecule need to be a small, have two reaction group and not bond at the activity. Okay, copolymerization of enzyme. Okay, copolymerization is performed with the multifunctional bridge molecule to yield an insoluble product. Usually an inert protein is also included. Okay, and last is the adsorption. Okay, what is the adsorption? Immobilization by adsorption method. Binding force are ionic, hydrophobic, hydrogen bond, or van der Waals force. Okay, van der Waals interaction. Binding is very simple. Stir together in a beaker, but it's reversible also. And the substrate addition can cause the desorption. Okay, this typical adsorbent we used for the adsorption to adsorb immobilization: cellulose, polystyrene resins, glass, alumina, silica gel, and cholinite we used for immobilized enzyme. Immobilized enzymes are enzymes which are attached or onto a surface of insoluble support. Onto the surface of insoluble support, we can say this is the adsorbent method. Okay, thank you.